We'll be looking at question 17, June 2019 paper. In this question, it's talking about healthy human blood needs to be maintained at a pH of 7.40, which is slightly alkaline, for the body to function normally. On a side note, eating lots of fresh fruits and vegetables, green vegetables, helps maintain this pH, making your blood circulate in your body very efficiently. Carbonic acid is a weak acid, H2CO3, which together with hydrogen carbonate ions acts as a buffer to maintain the pH of blood. The pKa value for the dissociation of carbonic acid is given here. pKa, explain in terms of equilibrium how the carbonic acid hydrogen carbonate mixture, this over here, acts as a buffer in the blood in the control of blood pH. How does it act as a buffer? And calculate the ratio of the hydrogen carbonate ion and the carbonic acid ratio in healthy blood. Explain in terms of equilibrium. When we're trying to explain in terms of equilibrium, it's a case of left or right. Is the equilibrium shifting? So let's make a start. You see, because it's a weak acid, hydrogen or carbonic acid, H2CO3, it partially dissociates to give you HCO3 minus and H plus. Now, because this is a buffer solution, there's a mixture, you've got a large reservoir of the conjugate base and the weak acid. And you've got a tiny bit of the H plus. So how does it act as a buffer? Let's explore. You see, with the addition, what is a buffer solution, first of all? A buffer solution is that, let me get the wording right for this, is where you add, where the pH is maintained with the addition of a small amount of acid or base. So the wording from the book, a buffer solution is a system that minimizes pH changes on addition of small amounts of an acid or a base. Now, by addition of H plus, what's going to happen is you've disturbed the equilibrium, you've increased the H plus concentration, and to counteract that, these extra H plus ions will react with the HCO3 minus and form H2CO3. So what's happening is that the equilibrium is shifting left. The equilibrium will shift to the left. Addition of OH minus ions, what's going to happen? There's actually two things here. First is that the OH minus ions will react with the H plus ions. This gives you water. This is worth a separate valid mark. Now, what you've done, you've actually decreased the concentration of H plus ions. And because you've decreased the H plus concentration of ions, the equilibrium will shift to the right to oppose that change and bring the concentration of H plus ions back up. So to oppose that change, the carbonic acid molecule will dissociate and form HCO3 minus and some more H plus, which opposes that change. And the equilibrium shifts to the right. Yep. Now, in terms of the ratio, what's going on here? Let's use a blue pen. You see, for the Ka expression, for a buffer solution, we use this HCO3 minus H plus over H2CO3. Does this equal H plus squared? No, it doesn't. No. Because you've got these two concentrations are not the same as each other. We've got a large reservoir of the conjugate base there. That's why. Anyway, I'm just testing you there. So you see Ka from the question will be equal to 10 to the power of minus the pKa value, which is 6.38. The H plus concentration, will be 10 to the power of minus 7.40. That's the pH that's come from here. And by working out Ka, let me highlight this. By working out Ka and the H plus concentration, we are then able to work out the ratio of the conjugate acid, and the weak acid. Conjugate base, sorry. Right, let me just work this out on my calculator. So 10 to the power of minus 6.38 gives you Ka. Let's divide that by the H plus concentration, which is 10 to the power of minus 7.40. So bringing that to the other side. And what that gives me, by doing that, the HCO3 minus over the weak acid concentration, this gives me a value of 10.471. So you could say approximately 10.5 to 3 sig figs. That means the ratio of HCO3 minus to H2CO3 is a 10.5 to 1 ratio, which the question was being asked by the examiners in the question. How does it act as a buffer? We've said that. In terms of equilibrium, left or right, calculate the ratio. We've done that as well. Yeah, I think that covers all the points. And yes, it does. Next question is asking you, explain in terms of red blood cells contain hemoglobin. Explain how ligand substitution using ligand substitution, how hemoglobin transports oxygen and why carbon monoxide is toxic. You see, before we even answer this, it might be good to refer back to the textbook under this section. And you can pause it here to have a read, but blood carries oxygen around the body due to the presence of hemoglobin, the iron-containing protein present in all red blood cells. Hemoglobin contains 4 protein chains held together by weak involuntary forces. Each protein chain has a heme group. The central metal ion heme group, Fe2+, which can bind to oxygen gas. That's a point there. As blood passes through the lungs, the hemoglobin bonds to the oxygen because of the increased oxygen pressure, which releases the oxygen. In addition, the hemoglobin can bond to carbon dioxide. This is the exchange. We inhale oxygen and we exhale carbon dioxide, which is carried back to the lungs. Carbon dioxide is released from the red blood cells and carbon dioxide is exhaled. Carbon monoxide. This is horrible stuff, poisonous. People who smoke expose themselves to large amounts of carbon monoxide, can also bind to Fe2+. The carbon monoxide is breathed in. Ligand substitution takes place where oxygen and hemoglobin is replaced by carbon monoxide. Carbon monoxide binds to hemoglobin more strongly than oxygen. That's what makes it so toxic. And what it does, it ends up starving. It prevents the oxygen. If it becomes too high, it can lead to death even. Terrible. So, coming back to the question, what are the main points? O2 bonds to Fe2+ in the hemoglobin. One mark. Ligand substitution takes place. Substitution. O2 is replaced by CO2 and carbon monoxide forms stronger bonds than O2. It binds to it something like 200 times stronger or irreversibly even, which then starves the body of oxygen, which can lead to serious fatal consequences. Ladies and gentlemen, that is the end of this question. I'll see you tomorrow.